Hi, everyone. Um, okay, cool. Hi, everyone. How are you doing? Yeah, thank you. Thank you for joining. I know it's pretty late in the day. So my name is Kenny Chen. I'm from EA. So our team basically builds and supports the EA app, which is the launcher of EA games used by hundreds of millions of people around the world. So today I'm going to present how I use Grafana to build a system that can effectively monitor the status of the app. So I know we have a lot of audience that are rooted in backend development and SREs, and I hope this is a slightly different story for you because we have different set of challenges. So as usual, if you have any questions, take a picture of this QR code, and we'll try to answer that by the end of the presentation. So cool. So I'm going to discuss, first of all, the scale of our problem and the visualizations that I used that worked or didn't work for us, and the math behind effective monitoring and large-scale root cause analysis. So let me start with a question. Have you been asked to monitor 200 metrics at the same time? OK, cool. I mean, for real, like you might picture something like this, but that's not the entire picture. That should be, if you only use one gauge for metric, that should be, the 200 metrics, the dashboard, something huge and overwhelming. So why do we do this? That's because we're monitoring an app that's running on user's machine. Like, unlike the microservices everyone talks about, an app is a monolith by design. Like, you can't split it further. And monoliths are just hard to monitor. Like, our app throws off 500 different events, and by combining them, you can get more than 4,000 possible metrics. So even, let's make a deal. Like, let's say, it gives you a 95% off. Like, that still gives you more than 200 core metrics. So this is the list of the metrics that we're looking at. Like, for example, crash rates of our own executables, crash rates of our games, login from our error from ourselves, from external partners, various kinds of update, game install, updates, repair error. Either way, they are equally important to our user experience, and we need to closely monitoring them all. And whenever there's a problem, we want you to know as soon as possible. And we have a different challenge. Unlike a backend service where you probably just monitor one version, we have multiple versions running at the same time. We need to monitor them all. And so this is the real picture. Like, you need one gauge per version, per metric to achieve full coverage for metrics. So not to mention that our version list keeps growing because we have weekly release that release new builds every week. And that's not the end of bad news, because we've actually tried. We've actually tried something like that. Like this. And we found that we can't really trust gauges. Because a gauge can, for example, a gauge can mean a lot of things. It could show the last reading. It could show the median. It could show the average. Like, if you have a dashboard full of gauges, it's really easy to make things up. Plus, gauges are kind of vague by design. Like, totally different situations can look exactly the same on a gauge. Maybe you have a pod spike. Maybe you have an ongoing incident. If the average is the same, they show up as the same gauge. But you need to take completely different actions. So gauges can sometimes be misleading, and they are not best for spotting issues. Then we realized that that visualizations exist on the spectrum. Like, on one end, you have gauges that are super simple, but not much information. And on the other end, you have time series that contain every data point in a history. That contain a lot of information, but they're not very easy to scan when you have tons of them. So none of these works well when you have a ton of metrics. So what we actually need is something that's both simple and informative. Our answer is status history. If you're not familiar with that, let me describe it a little bit. So a status history, you can think of a status history panel like a colored calendar. You can stack rows with different meanings of the row, and each cell, it's like a time block, for example, an hour, and we use colors to show good or bad based on thresholds. The key is it's got a time axis and it's color-coded. That makes it super useful for us. For example, you can quickly spot patterns. Like, it's easy to see which metric is improving or which one is in trouble. It also lets us show lots of app versions in a compact way. Instead of having a gauge for each version, we can just have one status history panel that can automatically display the most popular versions in just one panel. And it helps us spot different types of issues. Like if only the latest version is red, it indicates a regression. Like the previous versions are all green and the latest version is red, a bug. But if all versions suddenly go red at the same time, it's probably just an external outage. But here's a question. Where do those colors come from? Like we already enjoy the effectiveness of the color coding, but where those colors come from? Like if you just randomly pick a threshold, the same metric can look good or bad for no real reason. So, how to find good metrics? How to find good thresholds? This is very important. And here's my tip. So first thing to do, I think you need to check the histogram of your metric. So on the left, you see the typical normal time series that everyone knows. And on the right, that's a histogram of the same metric. The histogram shows how often each value comes up. In case you're not very familiar with histogram, here's how to read a histogram. So this basically tells you that in the past 7 days, the metric was at 1.5% for 22 hours. And it was at 2.1% for just 1 hour. This just shows the frequency of each possible value. And usually it should look like a bell curve, also known as a normal distribution. And this is not a coincidence. The central limit theorem actually says that if your metric comes from many independent random events, it should follow a normal distribution. And this often works for error rates. I wouldn't go deep into the math detail here. The important thing is, with a normal distribution, values shouldn't go too high above the mean. You can actually draw a boundary, draw a line. That's the boundary between what's likely happen and what's unlikely happen. So if you see a bunch of unlikely values, something's fundamentally changed. Maybe that's a new bug, maybe that's a new incident. So the boundary is a really good place to put your threshold for good or bad. In practice, it's really easy. Like for any time series, just calculate the mean, the standard deviation. Your threshold is just the mean plus 3 times the standard deviation. So in this case, the mean is 1.5%, and the standard deviation is 0.2%. So that gives you a threshold at 2.1%. You can see how good it fits into our chart. Okay, so here's a quick recap of why we are doing this. So we started with this overwhelming dashboard, and we realized that gauges are not really good for indicating issues. So we realized we had to use status history instead, and that gives you, the need for good thresholds. And by combining the techniques together, we get dashboards that work. This is through this dashboard, you can easily tell different types of issues like external issues, regressions, bugs fixed, and external issue that's resolved. So our devs after proper training, can review 200 metrics in about 10 minutes. And that makes it possible to always keep an eye on everything that's important. So before this would have taken hours or maybe never. And sorry, I'll be honest. Anyway, and with the solid thresholds, we actually set up alerts for every metric. So we have 24/7 coverage, not just when someone's logging. So I'll be super honest here. Before this, we sometimes missed critical issues simply because there were so many things to look at and things were not very obvious. Since we've set up this system, we haven't missed any critical bugs caused by our own code changes. Thank you. But we didn't stop there. So once you detect the spike, okay, you see an error that's error rates up, you naturally want to know what's the root cause. So for those familiar with the backend workflows, I know Grafana has been delivering a lot of super cool features that can help this enhance this workflow. But for us, that's a different challenge. That's because this is a typical backend setup. Like you have metrics, you have logs, you have traces. They're separate, and when you see a metric spike, you go to check the logs and to find the root cause. But our setup is different because our app doesn't send metrics or logs. You can't seriously send all the logs from a user's machine to our server. So we only collect a few anonymous JSON events. That's a standard approach. And those JSON events, they have the type, and they have fields that can fields as the context. So whenever you see things like this, like whether you like the status history version or the time series version, it's a spike. And what's actually happening behind the scenes is that we get a flood of JSON events like this. So each of them has the same type, but with different contexts. And those contexts can help us figure out the root cause. For example, like if we have a spike in game launch error, we can try to break it down by game ID. So right away, we see which games are causing the spike. That's the green one and the yellow one. And then we can test those games locally and try to reproduce the issue or even reach out to the game team. Either way, those are actionable insights. Or we might want to break down by app version. So that would tell us if maybe there's a regression in our new, release, and at least you will know which versions are being impacted. So breakdowns are not magic. Like you've seen similar things through Loki drill down, but you can achieve similar stuff just by using the group by it's not a transformation. Anyway, it's a query. So I think this is available in most data sources. You can build your own. So breakdowns are super useful, except that they don't scale. Let's do a simple math. We have 200 metrics. And for each metric, let's say we have 10 fields that's worth breaking down. That would give you another 2,000 panels. So that's just impossible to build or use. Let's say even if we build it, where are we going to put them all? Like, are we going to put them in the same dashboard that are already crammed with 200 metrics, 200 panels? We're devs, we're not search engines, so it's just not possible. So what do? I always think about the drive principle. So that is, don't repeat yourself. When you're faced with repetitive tasks, you should really think about turning it into a function. So that's the same here. Like all those panels are basically the same, just with different parameters. They have different queries, they have different breakdown fields, but they are essentially the same. So what we actually need is a function. Okay, give it the query and the breakdown field, and it gives you the right dashboard to use. And you can think about that. You can see how a dashboard URL is similar to a function call, starting by the function name, and then here's how you populate. Okay, here's how you populate the, okay, typical EA, anyway. Here's how you populate the variables. And by visiting this URL, you get the dashboard you need. That's simple. So don't actually hard code 2,000 dashboard, 2,000 panels like this. What you should do is you should use different URL parameters to represent them all. So this is the concept of what I call functional dashboarding. The core idea is that dashboards are not static pages. They are functions. You can call them by visiting the URL with different parameters, and you get the dashboard you need. I want to demonstrate how I use it in, how this works in action. Cool. Can we switch to my laptop, please? Okay, there we go. Thank you very much. So this is part of the dashboard that I show here. It's a simple dashboard with just 6 metrics. It's not the 200 metric one that I keep mentioning. So each row is a status history. These are metrics that we watch day to day, and we have errors like game crash, 3 games, a crash rate of one of our binaries. Okay, you can see how easily you can see issues from our dashboard, like this is completely green. Sorry, completely red. Anyway, so what I'm going to do is that, so for each panel here, I provide a link that's attached, that's already pre-populated with the correct parameters. I'm going to open 2 of them. So as you can see here, they show completely different content. Like the title is different, the metric is different. You can tell it's completely different. But one thing is the same. They are the same dashboard underneath. So they are essentially the same dashboard, just with different parameters. So scrolling down a little bit, on the left here, we provide a sample JSON event that's sent from our user, from our app. And there's a list of fields here that all of them are clickable. And I want you to pay attention to the panel on the right here, so this panel. I want you to see that as I click on the link language, user language, it's been updated to show the breakdown of this error rate by user language. And we can also break it down by a different field, like operating system. Okay, you see our users use a spectrum of Windows operating system. The key thing here is that there are so many fields here. They're just the fields that are all fields that are available in our user events that's sent to our server. And for some of the fields, I don't even know what they mean. Like I'll be really honest. Like the end reason, what's the end reason? I don't know. Content ID, offer ID. There's a lot of IDs here. I don't really even know what that means, but you know what I mean. Like whenever there's a bug or there's a spike, I can click on basically any of them. I can just freely click on any of them, and if I see some very dramatic change in distribution, I know that's there's a direction to investigate. So let's do a quick recap. Remember, at the very beginning, we were thinking about building 2,000 panels like this, and now we see the answer. Okay, so there's no need for 2,000 panels, just one dashboard that's really configurable, that's really functional. And okay, so I think we can switch back to that presentation. Nice. So here's how it works behind the scene. The breakdown panel always reads the dashboard variable to adjust itself. Like this is the query. You can see it's a variable. It's not any hard-coded term. And when you click on a field like operating system, it will update the breakdown term variable of that dashboard. And it doesn't need any external plugin or something. This is just a simple URL trick. So there's no development work. And essentially, this is just the data link of the table. And the link is configured like this. It starts with the link to its own dashboard. And then you need to prepend the cell value as the new breakdown term variable. And don't forget to append other variables so that you keep the state. And remember, don't tick this so that it's a direct refresh of the current tab instead of opening a new one. And that's it. So the benefits are really huge. Instead of having 2,000 panels or even it's a growing number, we have just one. It's configurable for anything we need, and people can explore freely, not just predefined routines. Like as I said, you don't even need to know what those fields are. Like if you see any distribution change, you know that's maybe the root cause. And we can use our events to the fullest. Anything that's available in the JSON fields are available to us. Last important thing, maintainability. For a system that's big, like this one, it has a big alert dashboard and more than 200 alerts, and you can't build it by hand. Ours is all generated from templates. So once you define a query, everything else is automatically generated by scripts. It can be really easy to extend, and we have pipelines that calculate the 3 sigma thresholds from history and rebuild everything every week, so it's always up to date. For the deep dive dashboard, that one is generic, so it basically needs no maintenance. So this is the overview of how the system works. We have a pipeline that refreshes the thresholds and rebuild the dashboard, rebuild the alerts, and all of them have customized links that's pointing to the sheer deep dive dashboard. So it's a large system, but there are some really actionable takeaways for everyone. So if you're using gauges a lot, I think you should try. You can give status history a try. It's really good, and I think you should really try the 3 sigma rules if you have staggered thresholds. If you want high quality staggered thresholds, and last thing, I think you can treat dashboards as functions to reduce redundancy in your system. And that's the end of my presentation. Thank you, everyone.